Okay, so we now revisit bulls and cow problem. I'm not repeating the explaining how to play this game. Please watch the previous lecture. Okay? The question is the same. Write a script to compute bool and assign the value to the num v. And the true and test sequence in the is x true and x test, which are given. Okay? This is our solution in module 3. Okay. But if you take a look at this one, the same operation, this operation is repeated. Only difference is this value, right? Okay. Again, the main purpose of the loop structure is the repeating the same operation by changing the iterator. Okay, we can replace this value as an iterator and can design the loop structure like this. Okay, if you see this structure, I is equal to 1 and then do this action, then go up, I is equal to 2 and do this the same action until the I is equal to 4. Okay, so when this condition statement is activated means true, I is equal to 2, this location, right? Otherwise, this action statement is skipped. Okay, so see this code is much simple and readable, rather than list of the same operation over and over. Okay. Does that make sense? Okay, good. All right. Now we have solved the bit harder problem. How to compute the cow? Cow is if the digit is present in the both trial number and the chosen number, but it is not the same location. This is called the cow. Okay, but in this case, how many cow? 3. Only 1 cow, right? Okay, but before solving the cow, let's solve this one first. Cow plus bull. What is this one? This become a number of the digits are present in the both sequence, right? Does it make sense? The bulls is the digit on the same location. Cow is the digit present under this two sequence is not on the same location. So cow plus bull is the number of digits present in the both sequence. In this case, that is 2, right? How to compute this? The programming logic is to just employ the nested for loop structure and inspect the individual pair made from these two variables. Okay, so make the 2 loop statement. II is for reading the true value, true digit. No, sorry. Digit from true, JJ, digit from test. Okay, so we just simply compare the x true at I location. The value of the x true I location is the same with the value of the x test at j location. Okay, if the same, we are increasing the num_c value. Okay, let's see this example in detail. I is equal to 1, JJ equal to 1. Is it true? No, that is a 1, 3. And then go back to JJ equal to 2. Only difference is X test number, that is a 2. This is a false, right? Until the false, none of a value in the X test is a 1. So num C is still 0, right? And then what if we know II is equal to 2 and JJ, when the JJ is equal to 2, this condition statement is true. That's why we can increase the num C value by 1. So num C is equal to 1. Okay, what about the II is equal to 3? II is equal to 3, and then JJ is equal to 1. This condition statement is true, so we can add another 1 to the num C, right? And II is equal to 4, there's no overlap the digit, so in the end, num C, 2. Do you get this? Okay. In the end, the cow number is to find out from the num C minus num B, number of bull, right? This is num C is not the number of cow. Num C is the cow plus bull, right? So you can minus a bull number and you will get cow. Okay, so now if you know the if statement or loop statement, you can solve this realistic bulls and cow problem. Okay, does it make sense? Break. Okay, break comment is to escape the loop structure in the middle of the iteration, to terminate the loop. Okay, for instance, so in this case, II is equal to 1 to 5, meaning that the iteration is the 5 times, right? But if you break, we don't need to do all the 5 times. Okay, but break statement will cause a termination of the smallest or closest and closing the while of the loop structure. Meaning that you have a nested, for instance, II is equal to 1 to 5, JJ to 5, and if you have a break comment here, you can only escape from this inner loop. Break comment is not escape the outer loop because you only escape one single closest loop. Okay? Alright, so here's the example. Okay, II is equal to 1 and go to this action. This condition statement is a false. And then you're assigning the 1 to the first location of the vector. Okay, go up. II is equal to 2. Condition statement is a false. Skip. Then 2 is assigned to the vector, right? So now it's a 1, 2, 0, 0, 0. Okay. Then what if II is equal to 3? II is equal to 3. And then this condition statement true. And then break. Okay. This break comment is a direct you to the end of the your inner closed your for loop structure. Okay. Important part is this line is skipped. Okay. Break is directly place you to the end. Okay. Does it make sense? But question is, so when we use this break statement, okay, here's the really good example. Okay, let's solve this problem. Find the first appearance location of A character in a character vector's name as a character sequence and assign its location to the LOC. I mean, single location, right? Because we are finding out the first appearance of the A. Okay, here's the sequence. Hello, I am Malab. Okay, and the number of sequences to find out using the numeral. Again, this is just a vector. Okay, only difference is the vector contains the character, not the numeric value. Okay, programming logic is this one: reading the character value in the character vector and then compare with A, because we are finding out A location. Okay, if yes, we are assigning this location to the arrow C. Okay, the first, okay, let me delete the break first. Okay, okay, so here location is initialized as 0, I is equal to 1. This one is not 8, 2, 3, 4, 5, 6, 7, 8, 9. When I is equal to 9, character sequence 9 is the A, right? So this condition statement is true. Okay? Condition statement true, so 9 is assigned to the location. Okay. The question is, do we need further processing? No. We just stop this process because the goal of this problem is you're finding out the first appearance of location of the A, right? We need to stop this process. You need to stop this loop process. So that's why you're putting in break. And then break, you drag you to this end, not this end. Drag to this end. Okay. Okay, what if you have a break here? What happened? Okay. I delete this one. What happens if there's no break comment here? Location become a 16, right? Why? This one is assigned a 9 here, but it keep going up, right? And then keep moving the test letter, and then once this I is reached to the 16, the 16 is assigned to the arrow C. In the end, you will get location is a 16. Okay? Depends on the presence of the break comment here or not, you'll get totally different outcome. Okay? Okay, good. Okay. So different from the for loop structure, condition statement determines continuation of the iteration or not, meaning that script keep repeating the action as long as the condition statement is true. Sorry. This is a not counted loop. Not counted loop. That's the major difference from the for loop structure. Okay, here's the structure. While, and you're putting your condition statement here, and then action inside of the while loop. Okay. So here, since the condition statements come first, so if the condition statement is a false in the beginning, you skip this part. Okay. the action will not be executed at all. Okay? Or maybe so you're doing action here, right? And then test this condition statement every single loop. But if you're setting up the incorrect condition statement, meaning that your action cannot change the condition statement to the false, so infinite loop can often occur, then your code does not stop on its own. Okay? So the risk of infinite loop. Okay? Here's the question. Can we sum the range value using the while? Yes. How? So here, you're going to sum to 1 to 10. What is the condition statement that we can design? One is your II, your value. You first design the value is the march from the 1 to 10. And you check to see if your value is within this range. Okay? So here's the sample. You set the num and value is a 0. And then your condition statement is like this. Num is less than 11. And num is keep increasing every single loop. Okay? And then adding this num value to the val. Okay? For instance, when is num is 0, num is 0, condition statement is true, right? So we perform this action and the 0 is assigned to the value, adding to the value, and the value is still 0, but num is become a 1. If num is a 1, condition statement is true and then go up. And then 1 is adding to the value. And the value is become a 1. And then num become a 2. Right? So condition statement is true, right? So we can keep repeating until the value is at that time the value is 45. If you adding the 1 to 9, and then num become a 9, right? So we are adding the 1 and num become a 10, right? So num become a 10. Still num 10 is less than 11. So condition statement is true. 10 is to add it to the 45, so value become a 55, and num become a 11. Okay, if the num become a 11, condition statement is a false, so you can go to the end without executing this action statement. Okay, this is how the while loop works. Okay, so if you see this one, basically condition statement, in the previous case, the condition statement is to determine the code execute the action statement. But in this case, condition statement is the kind of exit condition for the loop. Okay, the concept is a little bit different. Okay, let's solve another example. Find a location of the first third of the 5 in a vector. Assign its location to the LOC. For example, your input vector is this. What is the third location of the 5? First, second, and third. 1, 2, 3, 4, 5, 6. 6, right? Sixth location. So at the end of your script, location should contain the 6, right? That's your goal. Okay. How to write this code to do this? This is a very good example of the while loop usage. Okay, let's this code. Num5 is initialized with a 0. idx is index. This one is the index of the vector. Okay, num5 is less than 3 right now, right? We are increasing idx is 1, increment by 1, and then you are accessing the first element and then check to see if those are the 5 or not. Okay, it's not 5, right? Let's skip this one and then go up. Okay, num5 is still 0, right? So idx is become a 2. Second one is not 5. Go up. Num5 is 0. But idx is become a 3. Third location is of the vector is a 5. So we execute this script. Then num5 become a 1. Right? Go up. Still, num5 is not 3. So run it again, but idx become a 4. First location, that is a 5, right? And then the code execute this line, num5 become a 2, right? And then go up. 2 is still less than 3, but II is become a 4, and 5, or 3, 4, 5, and 6. If idx is become a 6, this one is a 5, num5 become a 3. So here num5 is a 3. That is not less than 3, so we can exit the loop. Okay. So here, when do we exit this loop? When the idx become a 6. So that's the location that we are looking for. Okay. Do you understand how this while loop structure works? Okay. Okay, good. So we can design the same program in a different way. Okay. Actually, this is my first script when I solve this problem. Okay. I place location inside the if statement like this, not the outside. Okay. So imagine that it's the same process, but imagine that if the idx here is the 6 become a 6, and then value is a 5, right? Condition statement is true. Num5 is become a 3, and then location value become a 6, and then go here, and then if you okay, in here's the num5 is become a 3, right? Because it's already 3, so we can escape the while loop, right? We can still get the location, third location 5 value using this code. Okay. But here, the difference is, in this case, we are assigned the location value only the one time. But what about this one? This one is, we are keep assigning the location when we detect the 5 from the vector, right? For instance, index is become a 3, location value is a 3, 3, and then idx is become a 4, location 4, and then idx is become a 6, location 6, but in this case we escape the loop structure, right? But why I prefer this method? You know, sometimes we made a mistake. Where? From this part. Okay? Let's assume that if we moved this one here, like this. Okay? Do you think this is correct? No. Why? For instance, here, okay, IDX is 6 and then num5 is, where is it? Num5 is 3. And then this, doesn't drag you to this end. You can run up to the end. So IDX become a 7, not the 6. So if you assign this IDX to here, location value is a 6, not the 7. So compare with the previous code. In this code, depending on this IDX location, your final this assignment statement should be different. But in this case, correct way to assign the location vector is IDX minus 1. Okay? Can you see the difference? The reason I put this IDX, this statement inside of the here is to avoid such a mistake. Okay? Depending on this syntax here or there, your final line is different. To reduce the mistake, I'm putting this line is inside. Okay? It's just kind of the skill to avoid a mistake. Hey, this example is you don't need to design the condition statement like this. You can just design condition statements like this. It's basically same. So number is a 5, become a 3. This one is a false. This one is a false as well, right? Okay. Okay, good. Okay. Actually, while loop statements can be completely replaced by the for loop and break. Okay. The idea is that when the number is a 5, number of 5s is equal to 3, then we just escape the for loop and terminate iteration. Okay? That's the same, right? Here's the example. How I write this while statement using the for loop structure. Okay? So here is II is vary from the 1 to 9. So when the II is equal to 6, num5 become a 3. So this condition statement is true. So you assign the II to the location because II is this location, right? And then break, and this goes to drag you to this end, and you're done. So location is 6. Okay. So basically, these two are same, right? But for me, I rarely use the while. That's why I rarely use the while loop, because we can realize the same functionality using the for loop. Now, another drawback is while loop, as I mentioned, it calls the infinite loop if I do not set a proper condition statement. But again, regardless, students need to know how the while loop works, and then you can also write a script using the while loop. Okay, good. All right, this is the last topic. I'll give you some hint for the next two model. Do you remember the dot product? Dot operation between the two vectors is basically element-wise the multiplication and summation of those values. Okay? This is the definition of the dot product. Let's see how write a script to perform this dot operation. Okay? based on what we learned, we can perform the element-wise operation using the loop statement. Okay. First, take a look at this script. Okay. We make vector ABVec to assign the value of the element-wise operation. For instance, so AB are the same size of the vector, and then we find out the number of element. That is, here is the 5. So we do the iteration to compute the element-wise the multiplication of each location. So in this case, we read the 3 and 5, and 3 times 5 is assigned to the first location of the ABVec. It keeps repeating until the II is equal to 5. So basically, we already learned how to, element-wise operations. So ABVec is exactly the same, the element-wise operation A dot multiplication of the B, right? We can get the ABVec using the for loop and the element-wise operation. Then we are making another loop structure to summing up all element in the ABVec variable. So we already learned about this one, right? We designed the I is equal to 1 to n element, and then read the value, adding those values to the AB variable. So finally, we get the AB. Okay. What's the issue of this one? We forget about this one first. But in this case, we use the same loop iteration 2 times. We can merge this loop structure as one to improve the efficiency. Okay. We can directly, in this case, summing this element-wise multiplication vector to the AB. Okay, accessing the the value at the II location of the A and B, and then multiplication and adding those values to the AB. Okay. Then final AB, the value is the same with this one. Okay. Can you see this improvement or the changes? Okay, good. However, there are much simpler way to do this operation. You can use the built-in function. Okay, let's do Googling the dot operation mallet. There is a function that can perform the dot operation. The function name is dot. Okay. So you can simply place the A and B in the dot function. This is how you use the dot function. Then you will get the AB value. So AB can be computed using this one-line operation. Again, the most basic operations are already built in as a function in MATLAB. Or you can use the operator. Okay? How? You can do the matrix multiplication between A and then B transpose. How does it look like? 3, 4, 5, 6, 8, 5, 6, 7, 7, 8, right? So like you can do the element-wise multiplication is a summation. That's the matrix multiplication, right? So with this operation, you will get the same AB. Okay? These two topics, built-in function and operator, will be studied in the next two modules. However, I would emphasize that this doesn't mean that you don't need to know how to use the loop statement. Loop statement and if statement are fundamental in the programming and are very important. Yes, you can realize some functionality using the built-in function or operator, but unfortunately, not all the operation. So that's why you need to know how to know this loop syntax that connect and place, built-in function to complete your program. We'll do a lot of the practice of the loop structure and if statement in the rest of all the homework assignment and tutorial. But we will try to minimize its uses by employing the built-in function and operator. Okay, that's it for today. Please watch the tutorial video and see you next lecture. Bye.